Imagine we have a program that reads an input with dice values and that repeats until we find the value 6. So this is the program right here. I'm going to change to split input output and to try this program. Let's try to throw a dice, and we have 2, and then we have 4, and then we have 3, and then we have 1, and then 5, and then 6. Maybe we have 4, and then 6. All right. So here, I will try this program, compile and run step by step. Dice value not 6. We read the dice value 2. It's not equal to 6, so we repeat until we get to the value 6. How many times do we repeat? Well, as you can see here, we repeated until we arrive to the value 6. So now imagine that I want to print how many times I had to throw one dice until I got the number 6. Well, I will introduce a new variable, int number of throws. I will initialize it with 0. And now each time I loop, in this while loop, I will add 1 to number of throws. We know how to do that. It's only number of throws plus plus, which means number of throws gets number of throws plus 1. Now at the end of the loop, I can printf something like we needed %d number of throws to get the value 6. And I replace %d with number of throws. Let's try the program. Compile, execute. So we read the first dice value. We go into the loop. Number of throw now is 1, 2, 3, 4, 5, 6, 7, and we print we needed 7 number of throws. Well, I could put 7 throws to get to the value 6. Is that correct? Well, let's count manually. In the input just here, how many throws do we have to get to the 6? We have 1, 2, 3, 4, 5, 6, 7. But wait, the number 8 is 6. So actually we needed 8 throws to get to the value 6. So let me correct this program here. First, we needed %d throws, right? But then it's not number of throws. It's number of throws plus 1. Why that? Because I started to count with number of throws equal 0. So I could do something else. I could do number of throws plus 1. So let's try that. Compile, run. 1, 2, 3, 4, 5, 6, 7. And then, because number of throws is 7, I will print we needed 8 throws to get to value 6. Because here I put number of throws plus 1. But the second option is to start counting with 1. So instead of number of throws defined to 0 at the initial point, at the beginning, I put 1 here. So I don't need the 1 here. Compile and run. 1, 2, 3, 4, 5, 6, 7. And we needed 8 throws to get to the value 6. So you got the point. Here, if you start counting with 0, then you should put number of throws plus 1. If you start counting 1, then number of throws is good. Now, let's simplify a little bit this program, a little bit more. Here I have a condition in the loop, while not 6. Well, I could replace not 6 directly with the comparison operator, just here. So if I put this instead of not 6 in the while, so I will copy and paste it here, I don't need the not 6 variable anymore. So I can get rid of not 6 here, I can get rid of not 6 here, and I can, and that is quite amusing, I can get rid of the update of not 6 here, and that simplifies the program. don't you think? Let's try if it is still working. Compile, execute. All right, we read the first value for the dice, 2. Is this dice value different of 6? Yes. So we go inside the loop. We read the second one, 4, and we update the number of throws. And we back again, we check the condition. Is the dice value different of 6? Yes. So we repeat, etc., etc. And at the end, because 4, 6, all right. So now the dice value is 6. So dice value is 6, so this is false. So we go out of the loop and we print we needed 8 throws to get to the value 6. All right, you get the point. So you know how to use the while loop with a direct comparison here. You could use different kind of operators here to compare two variables or a variable with a value. And also you know how to count how many times you've been through the loop. And don't forget that if you start with 0 to count the number of loops, well, you have to add 1 at the end of the loop, just like here. Try to play with it and to add a little bit more throws and to see if you understand everything.